Let's find the volume of the solid of revolution obtained by revolving the region bounded by the graphs of y equals x squared and y equals to 3 minus 2x about the x-axis. So we recognize y equals x squared as the basic standard parabola. Y equals 3 minus 2x is a line. Let's find our points of intersection. We set x squared equal to 3 minus 2x, and this is x squared plus 2x minus 3 equals 0. This factors into x plus 3 times x minus 1 equals 0, and the x coordinates of the points of intersection are minus 3 and 1. When x equal to minus 3, plugging it in to either line or parabola, y is 9, and when x equals 1, y also equals 1. So these are the 2 points of intersection between the line and the parabola, and now we can graph this region. So this is the x-axis, this is the y-axis. Here's the graph of the parabola, and let me stop right here. If this is minus 3 and this is 9, so this is one of the points of intersection, minus 3, 9, and if this is 1 and 1, we have a second point of intersection here, so the line comes down like this. The line was 3 minus 2x, so you know it has negative slope. Has to look like that. That is our region, and now we're going to revolve this region about the x-axis. So the way we are going to solve this is we're going to use the washer method. I'm going to select any x between minus 3 and 1 and keep track of this vertical slice. As this slice is rotated on the other side of the x-axis, it's going to end up over here, and 360-degree rotation will yield from the slice a washer that looks something like that. So the key solving this problem is to expressing the area of this washer as a function of x. We know that whenever we have a washer, it has a big circle and a small circle. If the radius of the small circle is little r and the big circle is big R, the area of the washer is the area between the circles. It's pi times big R squared minus pi times little r squared, or pi times the difference between big R squared and little r squared. So in our case, the volume is going to be the integral from minus 3 to 1 pi. Now we need to express the big R as a function of x. Big R is the y coordinate on the line, which is 3 minus 2x. We can square that. Minus little r is the y coordinate on the parabola, so that's x squared squared. And so the integral that we have here is going to give us the volume of this solid of revolution. So all we have left is the actual integration. So this is pi times the integral from negative 3 to 1. Squaring 3 minus 2x gives us 9 minus 3 times 2 is 6. So it's double that, minus 12x plus 4x squared minus x to the 4th dx. And this is a very easy integral. This is 9x. The integral of 12x is 6x squared, so minus 6x squared plus 4 over 3x cubed minus 1 over 5x to the 5th. All this is evaluated from negative 3 to 1. So plugging 1 in, we get 9 minus 6 plus 4/3 minus 1/5. And then if we plug in negative 3, we get minus 27. And the negative 6 times positive 9 would be minus 54. Then we have minus 3 cubed, which is minus 27 over 3. That's minus 9 times 4. That's minus 36. And we have negative 3 to the 5th, which is 243. Minus and a minus, that will be plus 243 divided by 5. So all we have to do is simplify this. And this is equal to 9 minus 6 is 3. Plus 4/3 minus 1/5. We have minus 27 minus 54 minus 36. That's negative 117. Minus a minus plus, so this is plus 117 minus 243 divided by 5. This is equal to 3 plus 117 is 120 plus 4/3 minus 1/5 minus 243/5 would be minus 244 over 5. The common denominator here is 15. 120 times 15 would be 1800. And then we need to multiply 4/3 by 5 over 5, so that's plus 20 over 15. And multiply 244 by 3, that's minus 732. And finally, 1800 plus 20 minus 732 is 1088 divided by 5 as our final answer. So the volume of the solid is 1088 cubic units. For more videos,